Okay, so today your agenda is pretty simple. Find your seats, same as testing seats. See your seating chart. I'll put the seating charts up in just a little bit. We're going to review our study guide. I have a video that will continue on with the study guide here. And then Unit 6 test. Okay. Now I know that your test is not scheduled till June 3rd, so after we review the study guide, you can start your test and just work on what you know. And we will continue your test after each SBAC testing session. We're going to have to split it up amongst the next few days. So you're going to have more than one class period to work on this. You'll have a little bit of time after you finish your next SBAC and again next week as well. So here's your seating charts for period 1. Pause the video so that everyone can find their seats. Here's period 3. Again, pause the video if necessary. Here's period 5, your seating charts. Pause the video when necessary. And Bobcat, all the same seats. Sit in the correct seats, please, Bobcat. Okay, so here's your study guide. Let's go over the study guide video. So it says the Fabulous 5 game costs 10 cents to play. Before the game, 30 coins, each with a different number between 1 and 30, are put into a bag. A player draws 1 coin from the bag. If the player draws a coin with a number ending in 5, he or she wins 25 cents. Okay, what is the probability of winning the game? Okay. So we need to figure out what are all the possible wins. So I'm going to write probability of winning. Okay. And I'm going to write down all the possible wins. So she can win with a 5, 10, 15, or 25. These are all the numbers that end with 5 between 1 and 30. So those are all the possible wins. So the probability of winning is 3 out of 30 because there are 30 coins and there are 3 possible wins, and that can be reduced to 1 over 10. Your answer may be 1/10, 3 over 30, or 10%, or it can be 0.10, no percentage sign here. Okay, and your last option could be 1 to 10 written as a ratio with a colon. Okay, so either one of these answers are correct. Same thing on your test. Okay, what is the probability of losing the game? Now, probability of losing, is all the chances of not winning. So if all the chances of winning is 3 out of 30, the probability of losing is the difference. Probability of losing is 27 out of 30. So if you don't win those 3 chances, you're going to lose 27 chances. That can be reduced to 9/10. Again, these two make up one whole. These two make up one whole as well. Okay? Either one of these are correct. You can convert this into percentage, 90%, or a decimal, 0.9 or 0.90. No percentage sign here. Again, you can write it as a ratio as 9 to 10. Okay. Now, if a C says if a player plays the Fabulous 5 game 15 times, how much money would you expect the player to win or lose? Explain your reasoning. Okay, so there's a couple things we need to figure out here. We need to figure out how much money they're spending. Okay, so spending money to play. Okay, and how much they are winning. Okay, how much they are winning. Okay. I'm going to subtract these two. I'm going to find the difference. Okay. Now, if this number is bigger, if I win more money, my answer is going to be negative. It's a little strange, or you can switch it around. Either one is fine. Okay. But I'm going to figure out how much money they're going to spend to play 15 times. Okay. So 15 games, 15 times to play, times, okay, it says 10 cents to play, times 0.10 or 10 cents, that means it's going to be $1.50 to play. Okay, so to play, I'm spending $1.50, and I'm going to play 15 times. Now my probability of winning is 10%. Okay, 10%. Now, if I play 15 times, okay, here's my probability of winning, 10%, which is 1 out of 10, and I multiply that by the 15 games that I play. The 15 games that I play, I end up with 15 over 10, which is 1.5. That means I'm going to win, okay, number of times wins. Number of times someone wins, okay? Now, I can't win a half of a time. So that means they are either going to win 1 win or 2 wins. So they can only win once or twice, or we expect them, not can only, that we expect them to win once or twice, okay? Because I can't have a half of a win. Okay, so I'm going to have 2 different events, just so you see what it looks like, okay? Let's do 1 win, okay? If I spend $1.50, $1.50, and I subtract 1 win. Now 1 win, for every win, I get 25 cents. So 1 win is 25 cents. 2 wins is 50 cents. Okay? So if I win once, 1 win, I spend $1 and I make 25 cents. That means I get I spent $1.25 is what I lost. Because I spent more than I won. Okay? For 2 wins, okay, if I have 2 wins, that's let's see, I still spend $1.50 to play. That's how much my cost to play, and I'm gonna win 50 cents. That means I still lose $1. Okay, lost. Okay, so I lost either $1 or I lost $1.25. Okay, so this would count as work to show me how much you spent, how much you made, and then showing how much I lost. Okay, these are expectations, not actual, because these are theoretical outcomes. Okay. Number 2, this is the one where a lot of people seem to have some trouble with. So let's go over this. It says Anna has 2 pens and 3 pencils in her backpack. Without looking, she will select a writing utensil. If she selects a pencil, she will take out an eraser. If she chooses a pen, Anna will toss a coin. If heads, she will take out a blue pen. If tails, she will take out a black pen. Use the space below to construct an area model. Okay, there are quite a few things here. This is what we need to do. We need to construct an area model, okay, for this given situation. Now, an area model is made up of 2 things, okay? The first event, okay, so event number 1, okay, that's this side, and event 2. Event number 2, okay, and that's the side over here. That's the top, okay? Because area is made up of 2 things, length and width, okay? Okay, so here's my area model. Again, area is made up of length and width, so 2 events, okay? My first event is 2 pens and 3 pencils. So I'm going to break that down over here. I have pen, pen, pencil, pencil, pencil. Okay. Now I'm just going to stick with my first event for now, and I'm going to break this down to the 5 parts that I have here. So I'm going to separate pen and pencil first. Okay. And I'm going to separate pens next. I'm going to use a pencil so that you can see the line is a little bit lighter. Okay. So pencil, and then pencil is broken down to 3 parts. Okay. They're all still equal, and I have 5 parts total. Now, before I move on to the second event, they do give me some information here. They do say that if she selects a pencil, she will take out an eraser. So if she picks any one of these three, she will get an eraser. So I'm going to highlight these all in the same color, or box them all in the same color. This whole section here, she ends up with a pencil and eraser. So this whole section is pencil and eraser. Okay, I know that already. And that section, that area, because it's an area model, represents 3/5, because it's 1, 2, 3 parts out of the 5 total. So I'm done with this section. Okay, I'm going to still write over it so we can see it a little bit later. It says if she chooses a pen, so if I get one of these two, then Anna will toss a coin. Okay, now a coin is 2 equal events. Okay, coin gives us heads and tails. Okay, she will take out, if she gets heads, so heads, she will take out a blue pen. Okay, so heads, she will take out a blue pen. Okay. Heads, she will take out a blue pen. So heads, I'm going to say blue pen, depending on which one of these it is. Okay, so this section is blue pen. Okay, if it's tails, there it is, we'll take out a black pen. So here, she's going to go ahead and take out a black pen. Okay, now what that means is we now have all of our sections taken up, every single one of them. Okay, now I had 3 fits there, okay, and here I have 2 equal parts left over. If I have 2 equal parts, and right now I have 3 fits, what I have left here is 2 fits. Now they're not divided horizontally like the pencils are, but they're still divided in half. Okay, that means the blue pen gets 1/5, and the black pen gets also 1/5. Now you could break this down to all the little sections if you like to. I'm usually more of a person that likes all these little parts, and then I can reduce. Blue pen is 1, 2 boxes out of a total of 10. So you can say 2 tenths, 2 tenths, and this one gets 1, 2, 3, 4, 5, 6 tenths. They're the same thing. They're the same thing. So this is our area model. Okay. Pause, rewind, play again if you need to, if you don't understand it. Okay. Now, what is the probability that Anna will take out an eraser? Now, here's my eraser. Okay. The probability that she'll take out an eraser is the same as the area. Okay, so if the area is 3/5, my probability of an eraser, okay, is the same, 3/5. You can turn this into a percentage, 60%. You can turn into a decimal, 0.60, no percentage here, or you can turn it into a ratio, 3:5. Okay. What is the probability that Anna will use a blue pen? Okay, what's the probability she'll use a blue pen? Well, blue pen's right there. Okay, so I'm going to write this down as probability of blue pen. Probability of getting a blue pen is the area that it represents, is equal to 1/5. Again, a percentage would be 20%. Okay, a decimal, you can say 0.2 or 0.20, both are the same. Do not put a percentage here, it will be incorrect. Or you can leave it as a ratio 1:5. 1:5. Okay, we'll continue the rest on the next video.